Xiphoid process. Who here is trained in CPR? So, right, we're trained to palpate the xiphoid process. Then you put the hands above that. How fast did you do? So, what's the current technique for doing CPR? What do we do, guys? Do we do breaths and chest pumps, or what do we do? If there's just one of you, what do you do?
Chest compressions.
Do chest compressions. Right? How fast should you do?
To the beat of staying alive.
So basically, if you forget everything else, right, just compress as hard as you can, as long as you can, as fast as you can, until somebody more qualified or with better equipment shows up. Okay, so we've got the clavicle. Who here speaks Spanish? Okay, what's the Spanish word for nail? Like a nail you hammer into wood? No.
Clavice.
Clavel. Clavel, right? So this comes from the Latin word for nail. It looked like nails from back in the day. Okay. So we've got a sternal end and then a acromial end. Right. So if you feel your clavicle, you'll feel that it curves in. Right. And this thing here, this is called a conoid tubercle right here. So this would be a right, or sorry, this would be a left clavicle. Okay. So on the exam or in quiz on Tuesday, I might ask you left or right for stuff like this. Okay. Then we have the, what's this? Scapula. So here is the scapula. Okay. So we got a couple of different things here. So we got the acromion process, coracoid process. This is called the glenoid cavity. And then we have the lateral border and medial border. This is the supraspinous fossa, and this is the infraspinous fossa. This is the subscapular fossa. Is this a left or a right scapula?
Right.
Okay. What do you say right?
I said it.
Okay, what do you say right?
I don't know, it just looks like
Okay,
it.
what's this here? That's the glenoid cavity. Is the glenoid cavity facing exterior or medially or laterally? It has to be lateral because it's the socket part of the ball and socket joint, okay? So, right, and then this is the spine of the scapula. You can actually feel that on your scapula. So, can this be a right scapula?
No.
Okay. Is the glenoid cavity in the right spot?
Nope.
No, so this has to be a left scapula, right? Because the glenoid cavity has to face laterally. Okay, so this would be a left scapula. Okay, all right. Then we've got the humerus, also known as the funny bone. Okay? So we got the head of the humerus. We've got the greater tubercle, lesser tubercle. This is called the intervertebralar groove or sulcus, also known as that bicipital groove, because the long head of the bicep goes up it. About halfway down, that's the deltoid tuberosity. Here are your epicondyles. So this is called the trochlea and the capitulum. Okay? This is the coracoid fossa, and then this is the olecranon fossa. So this articulates with the coracoid process of the ulna. This articulates with the olecranon process. So this is what limits flexion and extension. Okay. Yes, I can. So we got the two bones of the forearm. The one that kind of looks like a wrench, that is the ulna. Okay. So again, we've got the olecranon process and the coracoid process. So this is in the front. This is in the back. Here, to limit extension, is the olecranon process, the coracoid process, right? So this is the trochlea and the capitulum. So this goes around so this is called the trochlear notch, because it swivels around the trochlea. Okay? And this thing here at the end is called a styloid process, right? So do you ever use like to write on like a tablet or an iPad, right? What do they call that thing? stylus, right? So that's the styloid process, okay? Is this a right or a left humerus? I'll walk around real quick so you guys can take a look at it real quick. Okay. So this is what? This is the head of the humerus. This is the part that articulates. So this is the ball of the ball and socket joint. Which way should the head of the humerus be facing? Medial or lateral?
Medial.
Medial, okay? This is the olecranon fossa. That is posterior or anterior. So this limits elbow extension, so this must be
In.
anterior, okay? Is this correct? Right, so the head's in the right spot, but the olecranon fossa is in the wrong position, so this must be a left humerus. Okay. All right, then we got the ulna, okay, and then we got the radius here. So the radius, you've got the head of the radius, okay? This is going to articulate here with this thing called the radial notch. So it can pivot in its place. This is called the radial tuberosity. We talked about this in lecture. Okay, this is the attachment point, insertion point for the biceps brachii. So this allows us to flex and supinate our elbow. And then again here we've got the styloid process. Okay, so I'm going to walk around with these two together. Tell me if this is a left or a right.
Is it right?
Yes, sir. Yeah, we'll get to that in a second. Okay, so here's a super easy way to do it. So number one, in anatomical position, which one is lateral, the radius or the ulna?
Radius.
Radius in anatomical position is always lateral, right? So thumb side is radius, pinky side is ulna, okay? This here is the radial notch, okay? So which way does the radial notch have to face? It has to face lateral, okay? So, is the radial notch in the correct spot here if it's on the left?
No.
No, so this has to be a right ulna and right radius, okay? All right, super easy. Is this a left or a right? It's a right, okay. So don't worry about the bones of the wrist. We're not going to get into those for this class, but so we've got the first, second, third, fourth, and fifth metacarpal. We talked about this one. What's the fracture of the fifth metacarpal called? Boxer's fracture, very, very common fracture. Then we got the first, second, third, fourth, and fifth proximal phalange. First, second, third, fourth, and fifth distal. Second, third, fourth, and fifth medial phalange. Okay. Okay, pelvis. Okay. So we have a left and a right os coxae, which fuse with the sacrum in the back, okay, to make your pelvis. Okay, along with the and then the fusor in the front. Okay. So the bone on the top, this is called the ilium. Bone here in the front, this is the pubis. So this is the superior and inferior ramus of the pubis. And then this is the ischium. Right? This is the ischial tuberosity. This is what you're sitting on. It's a major attachment point. So this is what's called your, you ever like take yoga class, I'm talking about your sits bones, right? So this is your sits bones right there. That's what you're sitting. Okay. And this here, this is the ball and socket joint. This is called the acetabulum. So just like the glenoid cavity, it's covered in a large cartilaginous kind of a cup called a labrum. Right? So it's very, we talked about that, right? So Bo Jackson, his labrum. In overhead sports like pitchers, it's very common to have a pitcher with a torn labrum sort of a thing, okay? Here's a super easy way to tell if you've got a left or a right pelvis. Pick it up. Phone call. So this would be a left pelvis, right? So what do you got there, Trey? Other way. Flip it around.
So this is the speaker, the mic
There you go. See, a phone call. You guys are probably too young to remember the actual. Like, why we say hang up the phone? So.
It's just not satisfying to slam a cell phone down. We
Yeah,
can't do
it's
it
not
this
the same
day.
yeah, slamming it down. Okay. Femur, right? We talked about this. Largest, strongest bone in the body, right? So pound for pound, we cannot create an artificial one that's stronger, right? We create one that's lighter or stronger, but not both ways, okay? This is the head of the femur. So we got the greater trochanter, lesser trochanter. In between, this is called the intertrochanteric line. This is called the surgical neck, right? So if you have a hip replacement, this is where we're actually going to cut off the head. So there's two types of hip replacements you can do. There's a partial and a total hip replacement. Does anybody know the difference between a partial and a total? So partial hip replacement, we're either replacing the ball or the socket. And a total hip replacement, we're replacing both the ball and the socket. Okay, so that's what we're doing with that. Okay. This little nub down here, this is the gluteal tuberosity. We talked about that. That's the attachment point for the gluteus maximus. If this were an actual bone, you would feel here, this would be rough in texture. This is what's called the linea aspera. Literally means rough line. This helps attach your hamstring muscles to the back of your humerus, or your femur, sorry. And then we've got our medial and lateral condyles. And then this is the interpatellar surface, or the patella. Super easy way to tell if you've got a left or a right femur, right? Have the femur facing so that you can see the trochanters, okay? Put it on the table. If it leans to the right, it's a right femur. If it leans to the left, it's a left femur. So this would be a right femur. This would be a right femur. It's to the right, okay? Then we got the patella, okay? Super easy way, okay? So pretty much there's really two landmarks. There's the base and then the apex, which is the point. Point it apex away from you and put it on the table. If it leans to the right, it's a right patella. If it leans to the left, it's a left patella. So this would be a left patella. So this patella would not go with this femur, okay? All right, then we got the two bones of so that's the thigh, and then we got the two bones of the leg. Very analogous. What's analogous mean? Huh?
Analogous?
Analogous.
Like similar?
Right, has similar functions. So for example, a caiman, a crocodile, and an alligator are analogous, right? They serve the same niche and the same kind of ecosystem. How can you tell the difference between an alligator and a crocodile, guys?
Whether or not you see them in a while.
If you see it later, it's an alligator. If you see it in a while, it's a crocodile. Okay. All right. So we've got the tibial tuberosity. This is the attachment point for your patellar tendon, which is the four quadricep muscles. And then you've got your condyles. Okay. And then this is the medial malleolus. Okay. So is this a right or a left tibia? I'll walk around real quick, show you guys real quick. Is this a right or a left? Okay. What's this here? Medial malleolus, meaning it's going to be on the what? On the inside. Is the malleolus in the right spot? No, so this has to be a left tibia, right? Because the malleolus has to be on the medial side. So this would be a medial tibia. Okay. And then we've got the fibula. Okay, so real simple. Okay, we got the head of the fibula, and then we got the lateral malleolus. I'm not going to make you guys tell if it's a left or right, but this is a left. So easy way to do it is you hold on to it like they're a set of skis. Right, malleolus out. So if it fits in your thumb, in your left thumb properly, that's a left. If it doesn't, then it's a right. Okay, that's a okay. Then we got a foot here. Okay. So a couple bones that I want you to know. So number one, calcaneus. We talked about that. So this is called the calcaneal tuberosity. It's the attachment point for the triceps suri tendon, otherwise known as the Achilles tendon. Right, we talked about why that's there. And then this is the navicular bone. So the navicular bone articulates with the tibia and the fibula, okay? So this is the wrong one, right? But so if this were the correct one, it would be like this. So that allows your foot to go like this, okay? So we won't worry about like the navicular and the cuneiform bones. First, second, third, fourth, and fifth metatarsal, okay? And then when it comes to the toes, right, we use the same terminology that we use with the fingers. So first, second, third, fourth, and fifth, proximal phalange. First, second, third, fourth, and fifth, distal phalange. And then second, third, fourth, and fifth, medial phalange, right? So this little piggy right here, right? So this would be your fifth, your right fifth distal phalange. Questions on any of this? No? Okay. So, and then we talked about the two arches. What are the function of the two arches? Absorb shot, right? So we got a longitudinal arch and a transverse arch, right? So this helps with distribution of forces. So, how old were you guys when you figured out why the one little biggie was going to the market? Why was the biggie going to the market? It wasn't going to the shop.
For slaughter.
I was like 18 when I finally realized that. Yeah. So, questions on any of this material, guys?
So are we just gonna have to be able to identify the bones
Pretty
by
much, yeah. So,
holding
yeah,
them
so I'll ask you a bone, might ask you a couple of anatomical landmarks. That's about it.
Okay.
Questions on any of this material? No. Okay. So before I let you go real quick, so I want to talk about a couple of different things. Okay, so forensic anthropology, right? So like we talked about like the TV show Bones, right? So forensic anthropologists, right? So they're experts in determining, you can tell a lot about who a person was by their bones. So for example, when we find skeletal remains from what we know to be like medieval battlefields, okay? We can tell a lot about the type, who the person was, number one, by like the clothing and the armor, if they happen to be buried with their clothing and their armor, right? So if they're a knight, right, number one, they're probably gonna have bigger bones, period, probably better fed, better clothing, right, because knights were wealthy. But so for example, we can tell like who were archers, right? So for example, English longbow archers, right? So the English longbow, right, was kind of like the cruise missile of its time period, right? That's why the English were pretty effective fighting force for a long period of time. It took a lot of draw strength to pull back a English longbow, about 150 pounds of draw strength, which is the equivalent of taking a 150-pound dumbbell and pushing it out like that. So it took a pretty high amount of strength, okay? So English longbow was always held in the left hand, and then it was always pulled back with the right hand. Doesn't matter if you were right-handed or left-handed, right? So especially back then, you didn't really want to be left-handed. You were trying to hide that stuff. It was bad being left-handed back then. Okay, so how can we tell who the archers were on the field? So number one, they usually got bows by them, but if they don't have bows by them, how could a forensic anthropologist tell that they were there?
Bone density and the right and left.
Right and left, right? So there's a law called Wolff's Law. There's also another law called Davis's Law. Basically, they do the same thing. One's talking about soft tissues, one's talking about bones. So Wolff's Law states that bones are shaped in the line of the forces that they have. Okay? So you got a English longbowman, right? So a professional bowman, right? So they would spend a lot of time, especially during like the 100 Years' War. Who here has heard of the 100 Years' War? So it was a roughly 80-something year long war between England and France. So during that time period, a lot of Englishmen basically were paid by the government to just practice archery all day long, every day. Okay, so what would be some of the structural differences in the bones of a archer? So number one, the left forearm and arm would be significantly thicker than the right arm and forearm, right? Because of all the stress of having to keep that arm straight while you pull that bow back. Number two, you would find a notch right here on the zygomatic arch, right? Because what would they do? They would draw the bow back to right here. Over the course of years and years of practice, you would start to develop a notch here. And then, if you can find them with their hands intact, there's going to be a notch right here on the distal phalanges of the first and second finger, right? So you could tell a lot from that. How can we tell who the knights were if there's no clothing or any other kinds of stuff with them?
They have more density like in the upper chest.
They're going to have a bigger upper body in general, and they're also going to have slightly different shaped pelvises, and especially, what are these bones here, guys?
Femur?
Femurs, right? Why would their femurs be shaped slightly different?
Because they're holding a lot of weight.
What have they been doing pretty much since they were like 12 or 13? Spending all day on a horse. What's that going to do over time to the shapes of your femurs?
Bow it.
Gotta make them slightly bowed, right? They're quite literally bowed, right? We can do this. We can tell the same thing like when we go to ancient battlefields. We can tell like who were the Mongols or the Huns or other like nomadic horse peoples, right? So like you know, if we can find remains of who we knew to be Huns or Mongols, right? They were quite literally bow-legged. Or our, for example, our Neanderthal ancestor, Neanderthal, right? So the correct way to pronounce it would be Neanderthal, right? Because it comes from the Neander Cape of France. What was our Neanderthal cousins like? What were they built like compared to us?
Bigger brain.
They had slightly bigger brain case, right? So they were actually a little shorter than us, right? But stuck. So if our Neanderthal cousins still existed today, they would be dominating like middleweight, like wrestling and MMA and boxing, right? So they were shorter, stockier, but significantly more powerfully built than we were. I had a professor who said, you know, a Neanderthal woman would break your heart the old-fashioned way by just punching through your chest wall and pulling it out, right? They were extremely powerful human beings, right? So much so that when we look at the skeletal remains of Neanderthals, we see especially that their forearm bones are actually bowed because they had such powerful forearm muscles, right? So in hand-to-hand combat, we don't have a lot of evidence of it happening, but we do know it did happen. Right? In hand-to-hand combat, we were actually inferior to them. So it's still one of the big mysteries how we ended up like winning out as the dominant species over them, despite the fact that they were bigger and stronger. So in anthropology can tell us a lot about who an individual and who they were, right? There's also slight differences in like skeletal structure, bone structure between people who are of European descent, African descent, Asian descent, American descent, right, from the Americans. So there's slight differences in there. And right, so if you ever watch like those shows, right, that's how they're able to like recreate faces and all of that. So if you guys are looking for an interesting field to go into, you know, forensic anthropology is a fun one to get into. Any questions on any of this stuff? No? Cool. That's it, guys. You guys are welcome to stay and check all this stuff out, but if not, you're welcome to go for the day.